Today's lesson over scatter plots is a wrap up of what we were looking at and learning yesterday in class. So we have a scatter plot here that's representing the ages of married couples. We're comparing the wife's age to the husband's age. Recall that a scatter plot is the comparison of two numerical sets of data. So age for both a husband and a wife has numerical value. The first thing that they ask us to do is draw a line that best fits. Remember, when we draw that line of best fit, we want it to be approximately in the middle of the data. So we want the same number of data points above that there is below. Just do the best you can since we're doing this by hand and you're just kind of eyeing that information. So my first line, it looks like I have way more coordinates above than I do below. I like the slant of it. It seems to go with the trend of the data, but I just want to move it up slightly so it appears more even with the same number of dots above that it is below. Okay. Then it asks us to draw a conclusion based off of the data. Well, it seems as if it's going in a positive trend. How do I know that? Just like we know when it's a positive slope, it is going uphill. So some conclusions I can draw is that it is going in a positive trend. Okay. I can also conclude that as the husband age increases, so as husbands get older, the wife's age also tend to get older, which is what makes it a positive trend. So as the husband's age increases, the wife's age also increases, which isn't always the case because sometimes you have these little outliers off to the side where you have like a 50-year-old husband with a 62-year-old wife. So if we think about this in real life, most of the time, a husband and a wife's age are about the same. They're around the same age, but sometimes you have outliers where someone in that relationship may be significantly older or significantly younger than their spouse. But for the most part, with these 179 married couples, they tend to be close in age. So as the husband gets older, the wife's age also increases as well. So what are we going to use with these scatter plots? We're going to be able to learn how to read them and use that to answer various questions. So this scatter plot, it's comparing two sets of numerical data. The first set is it's comparing within a smoothie how many grams of sugar there are, so that's a numerical value, to how many calories are in that smoothie. And they did this for 10 different smoothies. So question A asks, how many calories are in a smoothie that contains 56 grams of sugar? So we're basically reading the plot. So if I go over to 56, that's in between 54 and 58, I'm going to find my data point that lies on 56. So there's my coordinate, and it's asking how many calories are in that specific smoothie, and there are 270 calories in that smoothie. Question B, how many grams of sugar are in a smoothie that has 320 calories? So now we're starting with our 320 calories. So I'm going to find my coordinate or the data point that has 320 and then go down to see how many grams of sugar. So it has 70 grams of sugar. Part C. What tends to happen to the number of calories as the number of grams of sugar increases? So if I look at the trend of my data and I try to draw a line that best fits again, so the same number of coordinates above that there is below, it looks like I have a positive trend once again. So that means as the sugar increases, my calories also increase, which makes sense. So the more grams of sugar you have, the more calories there's going to be in that smoothie. So we have 3 different types of correlations that we can identify with. So a correlation is determining what the relationship is between the 2 numerical sets of data. These are very similar to slopes. So if I draw a line that best fits, so same number of data points above and below, I can see that this is a positive correlation. So that means as my X values increase, my Y values increase as well. They move in the same direction. A negative correlation, just like a negative slope, goes downhill. What does that mean in terms of the data? As the X values increase, my Y values decrease. They actually move in opposite directions. Now, no correlation, you cannot draw a line that best fits because the data is just so far apart, it's so far spread out that there isn't one line that has the same number above and below. So this means that there is no relationship whatsoever between whatever this data set is. So there's going to be no pattern. So there's not going to be an increase or a decrease. It's just too scattered and too all over to even make any sort of conclusion other than the conclusion that these two just don't have a relationship whatsoever. So what are these going to look like? So if I look at this scatter plot, we're comparing the age of somebody, so that's a numerical data, to how many vehicles they own. So looking at the scatter plot alone, okay, this is an example of no correlation because there's no line. The scatter plots, or the coordinates, are way too far apart to have a line of best fit, which makes sense. How old you are has nothing to do with how many vehicles you are. You can be 16 and own 20 vehicles. You can be 55 and own 1. So there's no exact science or relationship between the data points. So there's no line of best fits. I also made this table or this scatter plot into a table so we could analyze the X values. Now, as the X values and the Y values, as the X values increase, so as I'm increasing, you're going to see that there's no pattern. We go down by 3, up by 4, down by 2, down by 4. There's no consistent pattern. Up by 2. There's no consistent pattern. We're just all over the place. So this results in no correlation. Our second example, we are comparing the temperature outside, so that's numerical data, to the number of coat sales. So if I try to draw a line that best fits, I can because the data points are close enough together, and I can see that it is a downhill trend. So from the graph alone, I can tell that this is a negative correlation. If I look at this as a table, my Y values are increasing. Unlike a line, it doesn't have to be a constant rate of change. We're just looking for patterns. My Y values are decreasing. So they're trending in opposite directions. So because of the downhill nature of the graph, and because one value is increasing while the other decreases, this makes this a negative correlation. So it makes sense. The lower the temperature is outside, the more coats that will be sold. or the opposite. The higher the temperature is outside, the less number of coats that will be sold. Our last example is comparing the stopping distance of an automobile. So how fast a car is going to how long it takes the distance for it to stop. So I can draw a line of best fit through my data and see that it is trending in an uphill direction by just looking at, as I said before, the slope. As I compare the x values to my y's, my x's are increasing. If I look at the trend of my y values, they're also increasing. So they're moving in the same direction. For both of these reasons, we have a positive correlation, which makes sense. The faster a vehicle is going, the longer it will take to stop.